yes, the letter C stands for carbon. That is correct. H is for hydrogen, N for nitrogen, and O for oxygen. Remember that abbreviations on the periodic table can in fact also have a lowercase letter. So for example, H stands for hydrogen, but HE would stand for helium. It's still just a single atom, so remember that abbreviations can either be one letter or two letters with the second one lowercase. Okay, now number of atoms, remember, comes from the subscript right after the abbreviation. So 6 comes right after the letter C, so that means there are 6 carbons. 5 comes right after the letter H, which means that there are 5 hydrogens. Cross those ones out. N right here has a blank, and everybody in the chat box, a blank subscript actually counts as what? A blank subscript actually counts as what? Tell me in the chat. Blank subscript counts as what? Excellent. I see Shelbs in the chat box. Again, it doesn't mean 0. If it meant 0, I would just delete the N. But yeah, it just means 1, because anything times 1 is still itself. So N times 1 is still going to be nitrogen, so scientists don't bother writing it. So again, the correct answer here is actually 1, not 7. And then taking a look here, 2 is the subscript for oxygen, and so there are 2 oxygens. We are going to apply this again at the end of our session, so I wanted to make sure that we understood it before we get started. Let's go ahead and jump into this. This is a reminder, please do not share contact info during classes for your own security reasons. Please remember to participate often and well and make sure that you are behaving appropriately. And don't forget that Class Connect sessions are recorded and distributed for learning purposes. No, there are definitely a lot of compounds that have way more than just 2 oxygens, Shelves. If you email me, I can always look one up for you, for example. But for example, sugar has 6 oxygens, so it's C6H12O6. So sugar has 6 oxygens in it per molecule. All right, so this is a reminder that attendance is this is a reminder to raise your hand for attendance. So here is the links to the attendance. All right, there's a link for my class, a link for Mrs. Sepulveda's class in the chat box, and start of class word starts with the letter B. You'll see it in the chat. I'm not going to say it out loud because we are recording. Thank you, Stephen. I see your check mark. I need everybody to raise their hands. If you do not raise your hands, you are not participating, which means you will not get attendance. So I need 20 more seconds. Here we go. Raise your hands. 5 seconds remaining. All right, waiting on raised hands from Kamari, Monique, Dion, Aria, Eric, Christopher, Tayan. Waiting on Timothy, Jaden. Let's see here. And Alexis. Monique, Dion, Aria, Eric, Timothy, Jaden, Alexis. I'm going to go ahead and start private chatting people. Again, you do need to be responding. So let's go. All right, here is a private chat for you, Monique. Dion checking in with you. Eric checking in with you. Again, please respond. Awesome, Omar. I see your chat. Thank you. Timothy, waiting on you. Private chatting you. Please respond either in the chat or on by raising your hand. And Alexis checking in with you. All right, perfect, everybody. Last chance. Again, Monique, Dion, Eric, Timothy, Jaden, and Alexis. Hello. Raise your hands or respond to that private chat I just sent. 10 more seconds to either raise your hands or respond. All right. Give me a moment, everyone. All right, everyone, let's go ahead and keep on moving. All right, so today we are on day 37 out of 60. We were taking a look at the mole and molar mass. So let's go ahead and jump into that. We're going to learn how many atoms are in a mole of an element. It's actually going to be the same number of atoms that's always in a mole of an element. We'll talk about how to find molar mass from the periodic table for an element, and then calculate the molar mass of an overall compound. And today we will be working on the 4C notes. Let's go ahead and get those open as well. And again, please raise your hands once you have those open. Mrs. Sepulveda is not feeling well today, so she's out for today, but I will be here still, so that's why we're still having a class. All right, so please open those up. You have 30 seconds to get that open and ready to go, or to tell me that you are going to take pictures, write notes, take screenshots, and you'll be filling it out later. That's fine as well. No, it's not a cold illness. She has a migraine, so it's very hard to talk and teach sometimes when you have a really bad migraine. 15 seconds remaining. Let's go. 30 seconds. All right, Kale. Stephen in the chat. Omar, Tayan, Christopher, Annabelle. Raise your hands or respond to me in the chat and let me know that you are good. Raise your hands or respond in the chat. Dion, make sure you open up your notes. Links are in the chat box. Just scroll up a little bit, and don't forget to also get your notes. Awesome. Omar, do you have your notes open? Let me know if you're good. Awesome. Thank you, Dion. Perfect. Perfect, Omar. All right, let's move on. All right, what I want to know, how many eggs are in a dozen? How many years are in a decade? How many people are in a duo? And how many people are in a trio? Grab your whiteboard tools, write the answers up on the board for me. If for some reason your whiteboard tools are not working, that's not an excuse. Just put your answers in the chat box. Let's go, let's go. Participate quickly. Again, often and well. That is my request. I need you participating often and well. Thank you. I see Skylar in the chat. Malin Shelbs. Jalen, you're funny, Shelbs. I see Patrick, Skylar, awesome. Get your answers up there. I see Ignacio on the board, Camilla up on the board, Daniel on the board. See Annabelle working, Kamari up on the board. Sorry, Annabelle, I'm gonna just delete that one. Perfect, looking good. Adriana. Perfect, everyone. All right, let me go ahead, pause those stools. Let's go over this. I saw tons of participation in the chat, but let's also go over it up on the board. How many eggs are in a dozen? You are absolutely correct. There are 12 eggs in a dozen. There are also 12 donuts in a dozen, and 12 cats in a dozen, and 12 elephants in a dozen. So it does not actually matter what you're talking about. If you say dozen, you know it means 12. Same thing with duo. There can be two people in a duo, 2 dogs in a duo, 2 cats in a duo, 2 elephants in a duo. Does not matter. A duo means 2, a trio means 3, and a decade will mean 10. A decade will mean 10. So the whole point here is that words can stand for numbers. Smiley faces, emojis, if that makes sense. Words can stand for numbers. I have no idea, Stephen. I don't keep track of that. You have the amount of notes that I feel are necessary to understand what's going on. Perfect. All right, so in the same way today, we're going to learn about a new word, and that word is the mole. Not like a mole like on your skin or a mole like the rodent. A mole in chemistry stands for a certain amount. Just like a dozen means 12, a mole means 602. Let's see if I can get this right. 602. Oh no, I lost my, hold on. Give me 1 second. Let's take a look here. All right, it stands for 602 sextillion, 214 quintillion, 179 quadrillion. Atoms, molecules, particles, dogs, cats, butterflies, donuts, etc., etc. Not the rodent. Yeah, all right, so it's a big number. Again, this makes sense though when we're talking about things that are really tiny, right? A single atom, you can't even see it even under a microscope. So in order to count atoms, when we have an amount that we can see, it makes sense that it would be a lot of them, okay? So taking a look here, obviously it's not easy to say 602 sextillion, 214 quintillion, 179 quadrillion. Even I had trouble saying that and had to look it up. So a much easier way to say it, please be quiet. A much easier way to say it is 6.02 times 10 to the 23rd particles, atoms, dogs, donuts per mole. Okay, this is also called Avogadro's number. We're going to go over in just a moment that this is called scientific notation. This way that we write it, and scientific notation still is the same number. It's just a lot easier to write it, a lot easier to say it. Please note that when we do use a calculator with this number, which you will be doing, your calculator might not have a button that says like times 10 to the. That little caret means to the, it means an exponent. So instead it might use a button that looks like a capital EXP, or a lowercase exp, or a capital E. Same thing, 6.02 exp 23 still means 6.02 times 10 to the 23rd. Smiley faces, emojis, if that makes sense. All right, again, we're not going to use our calculators for this number today. We'll use calculators for something else, but we won't have to yet use this number in a calculator. I'm just giving you a heads up because you will be. All right. Yeah, and just as a note, please note that calculators also have a lowercase e. Please never use the lowercase e. Lowercase e stands for a different number in math. Okay, now anyways, this is going to be number 1, Avogadro's number. Fill in the blank with the word number. Capitalization does not matter, but spelling does. You have 20 seconds to raise your hand for numero uno in your notes. If you missed opening up the notes, here are the links to your notes. All right, so there's Mrs. Larkin's links to the notes. Here's Mrs. Sepulveda's. Moses, you just came in late, so make sure you scroll up and grab the attendance. The attendance will be disappearing from the chat box in 4 minutes. All right, friends, we're waiting on Bryce, Kamari, Derek, Patrick, Tayan, Angelo, Adriana, Canyon, Omar, Steven in the chat, Skylar, Dion, Alan, Moses. Please raise your hands if you are good on number 1 in your notes. Thank you, Dion. Thank you, Moses. All right, awesome, Omar. I see you in the chat. Steven, you good? I think that was your green check. I'm not sure. I think you're good. All right, Patrick, Skylar, Taylor. You're my last 3. I need you responding fast. We have a lot of stuff to get through. And if I have to say your names over and over again, it's going to slow us down and we'll have to go into passing period, which I don't want to do and you don't want to do. So let's go. All right, thank you. Just waiting on Skylar and Patrick. Please stop. Okay. Oh, gotcha. All right. Thank you, Steven. All right, Patrick, checking in with you. Please stop. And Skylar, checking in with you. Yes. All right, there we go. Perfect. All right, I'm going to go ahead and keep on moving. Here we go. So just so you know, just so you can kind of see it happening in action again, scientific notation, we'll go over this more later, but when we multiply by 10 to an exponent, again, it kind of takes that first number that has a decimal and it moves the decimal so it's a much larger number. So 6.02 times 10 to the 23rd is the same as saying 6.02 times 100 sextillion. So 1 with 23 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So this big number. And when you multiply something by that big of a number, all right, it gives you this really big number down here. So smiley faces if that makes sense of how we got from 6.02 times 10 to the 23rd actually equaling this huge number. 6.02 sextillion, etc. Okay, same thing here. If you were to take that and move this decimal 23 times. I can't draw on the board if you're doing that. If you move this 23 times, all right, you would end up seeing that this would get us all the way to the end. So again, that's where that number 23 comes from in our exponent. All right, this is number 2. Fill in the blank with the word scientific and only the word scientific. You have 20 seconds. Capitalization does not matter, but spelling does. Okay, you can turn it off when it's done. Thank you. I see Steven in the chat. 10 seconds remaining. All right, looking good. Who are we waiting on? Again, if you just joined us here, we are in our notes. Please raise your hand once you have your notes open. Waiting on Aria, Patrick, Christopher, Tayan, Omar in the chat. I see Steven in the chat. Waiting on Skylar, Alan, and Moses. Again, the more I have to say your names, the longer it takes, and the more we go into passing period, which I don't want, you don't want, so let's go. Let's make it easier for our classmates and ourselves. Tayan, Skylar, thank you. I see Omar, Steven in the chat. Just waiting on Skylar and Moses. Hello. Skylar and Moses. All right, checking in with Skylar. Sorry, I have a timer going off somewhere. All right, I'm going to clear out the chat. We won't have our attendance anymore. All right, you okay there, Ignacio? All right, Moses checking in with you. Moses. All right, let's go ahead and keep on moving, everyone. All right, so let's go ahead and talk about how this how we can use this for our periodic table. So remember, we already learned that in Unit 1 that atomic mass is the number at the bottom. Okay, so the atomic mass of an atom, the number at the bottom, that tells us how much the protons plus the neutrons, the mass that equals. So carbon is equal to 12 AMUs because it has 6 protons, 6 neutrons. However, the cool part is this actually is also the molar mass of carbon. So what that means is it is actually scaled up also the mass that you need of this element in grams to give you 6.02 times 10 to the 23rd atoms of this element. Again, that's why moles are so convenient, because 12.011 grams of carbon is something that you can see. All right, that's about here, I'll show you. That's 12 grams is about the mass of 2 pieces of paper. So 2 pieces of paper. So if we have this much mass of carbon, the equivalent mass of carbon, then that would tell me I have 1 mole of carbon, and therefore I'm looking at 6.02 times 10 to the 23rd atoms of that carbon. Smiley faces if that makes sense. 1 mole of carbon will always equal this many atoms of carbon, and I can actually weigh that out. I can weigh it out. It weighs 12.011 grams of carbon. Cool beans. All right, we're going to practice it 4 times, and the 5th time you will have to do on your own. So if it's not clear yet, it will be by the time you get to your 5th chance. This is number 3 in your notes. Fill in the blank with the word molar and only the word molar. Spelling does not matter, or sorry, capitalization does not matter, but spelling does. 20 seconds, go, go, go. Raise your hands. 10 seconds remaining. Bryce, Kamari, Monty, Aria, Michael, Christopher, Tayan, Adriana, Dion, Moses, Jaden. All right, our time is up. Monty. Omar in the chat, Stephen in the chat. Dion, Moses, Jaden. Please raise your hands if you are ready to move on. Thank you, Stephen. Thank you, Omar. Looking good. All right, Dion, waiting on you. I'm going to check in with you in a private chat. Otherwise, please raise your hand. All right, Dion, checking. Oh, perfect, Dion. I see yours. Jaden, just checking in with you. Jaden. All right, Jaden, you're good. Ignore my message. I'll delete it. Thank you. Kamari, open up your notes. Make sure you're on number 3. All right, I'm going to go ahead and keep on moving, everyone. All right, so let's go ahead and practice this. So let's take a look at sulfur. I look at the bottom of the box for mass. So what is the mass of sulfur? What is the molar mass of sulfur? Go ahead and tell me in the chat box. Look at the bottom, and in the chat box, everyone tell me what is the molar mass of sulfur. Thank you, Shelbs. Thank you, Ignacio Shelbs. Yeah, make sure you include the decimals. Thank you. Yeah, we want all the decimals. Yeah, it's going to be 32.06, and units are going to be grams per mole. Now, again, what this is telling you that there are 32.06 grams of sulfur in 1 mole. So if I measure out 32.06 grams of sulfur, which is about half the size of an apple, half the mass of an apple. So half an apple's worth of sulfur, I am looking at 1 mole of sulfur, which also means I'm looking at how many atoms of sulfur. Again, this is going to be our magic number. This is going to be our Avogadro's number. So again, our magic number today is 6.02 times 10 to the 23rd, and in this case it's atoms. Could be dogs, could be cats, could be donuts. In this case it's atoms. Everybody, I want you to practice writing that number in the chat box. Again, 6.02 times 10 with a little caret means exponent 23. Go ahead and practice that in the chat box. I know it's kind of a headache to write, but we got to practice it because you need to be able to do this on your own in today's notes and in your project. So let's go. I see Camilla, see Miles practicing, I see Shelves practicing. Thank you, Malin. Steven, perfect. Awesome. All right, let's go ahead and try molar mass of calcium then. Again, look for the number in our box. What is the molar mass of calcium? Please use units. We just went over the units. What are the units for molar mass? Don't give me naked numbers. Put some clothes on them. There we go. Thank you, Steven. Thank you, Miles. Just make sure to put your units on them next time. I see Shelbs. Alan, make sure to include units next time. Again, molar mass. Please stop climbing on me. It's very distracting. There we go. Awesome. Yeah, it's going to be 40.078. I see lots of people in the chat, grams per mole, so I'll go ahead and write it up on the board for us. Again, that's coming from the bottom of the periodic table square. Again, you need to be able to do this in 2 slides, so make sure you're practicing with us. Now, again, how many atoms are in 1 mole of calcium? How many atoms are always in 1 mole of anything? Tell me in the chat box. This is our magic number that we just practiced. What is the number that always equals 1 mole? Awesome. I see Camilla. I see Alan, I see Miles, Malin, Steven. Yeah, don't forget that first part, 6.02 Shelbs. Yeah, it's going to be 6.02 times 10 to the 23rd atoms. Now, again, you might be like, okay, but Miss Larkin, right, why is a mole of calcium, why does it weigh more? Right, it weighs 40.078 grams, which is a little bit more than half an apple. Well, this is like saying that this is the difference between a dozen eggs and a dozen bowling balls. Even though you have a dozen of each, they still weigh different amounts because a single egg is smaller, and therefore a dozen of that smaller object will weigh less. Same thing with bowling balls. A single bowling ball is larger, and so a dozen of those will overall be heavier. So calcium, a single atom of calcium is larger than sulfur, and therefore a mole is going to overall add up and be larger overall. So even though you still have the same amount, just like a dozen of eggs and a dozen bowling balls is still 12 of each, even though we have 1 mole of sulfur, 1 mole of calcium, which is still 6.02 times 10 to the 23rd atoms each, the calcium ones will end up weighing a little bit more. Smiley faces, emojis, if that makes sense. Again, just imagine bowling balls versus eggs. It's the same concept here. Calcium atoms just weigh a little bit more, so overall, a mole of them weighs a little bit more. Beautiful. All right, everyone, this is the answer to number 4 and number 5. You do need to check off both the molar mass and the number of atoms for both of them. So you should end up with 2 check marks for number 4, 2 check marks for number 5. You have 30 seconds to get those done. Go, go, go. Raise your hands for number 4 and number 5. No worries, Stephen. You're good. You've been participating the whole time. 15 seconds remaining. Raise your hands. 2 answers for number 4, 2 answers for number 5. 5 seconds. All right, Tayan, Angelo, Omar in the chat, Dion, Jaden. Thank you, Omar. You raised your hand. You're good. Awesome. Steven, I see you. Dion, hello. All right, gonna check in. Either raise your hands, check in with me, or you won't be able to get attendance. Hello. All right, let's go ahead and keep on moving. All right, let's try xenon. Everybody in the chat box, what is the molar mass of xenon? We should be able to do this lickety-split now. Oh, I felt so old saying that. Tell me in the chat box, what is the molar mass of xenon? Take a look at its box here. Take a look at that bottom number, molar mass of xenon. Don't forget your units. No naked numbers. Yes, it's grams per mole. Perfect. I see lots of people in the chat. 131.29 grams per mole coming from this bottom number right here. And therefore, how many atoms are in 1 mole of xenon? How many atoms are always in 1 mole? That's our magic Avogadro's number. Practice typing it out. I know it stinks that we have to type it out each time, but it's good to practice. You will eventually want to have this number memorized. Excellent. Thank you, Miles. Thank you, Annabelle. Annabelle, don't forget the times 10 to the. Yeah, because otherwise it's not the same thing. All right. Otherwise, 6.02 is a really small number. Yeah, 6.02 times 10 to the 23rd. Again, that gives us 602 sextillion, which is a really big number of atoms, okay? So, I'm going to include my units here. Should be atoms. Awesome. So again, a mole of xenon, that's about 2 apples worth. 2 apples worth of xenon. If I were looking at 2 apples worth of xenon, I would know that's 1 mole of xenon, and I would know that there are 6.02 times 10 to the 23rd atoms of xenon in there. Again, the reason it weighs more is because xenon individual atoms are larger. So just like an individual bowling ball is larger than an egg, a dozen bowling balls weighs more than a dozen eggs. In the same way, a mole of xenon will weigh more than a mole of sulfur or calcium. All right, let's do gold up on the board. Grab your whiteboard tools, write for me on the board or in the chat. What is the molar mass of gold and how many atoms are in 1 mole of gold? Let's get your answers up on the board, preferably. If you need to, you can write it in the chat box, though, if your whiteboard tools are not working. Xenon is just a noble gas, just an element, one of the elements that we don't talk about a lot. I can see if I can grab a picture for you. Awesome, there we go. Yep, here's our molar mass. I see Ignacio's answer down here. Perfect. I see lots of people in the chat box too. Awesome. I would agree with that. So taking a look here, molar mass of gold comes from this number down here. Absolutely, in grams per mole. And in 1 mole of gold, again, there will still be the same amount of atoms. Again, even though it's heavier, about 3 apples worth of gold, it's still going to be the same amount of atoms. All right, let's go ahead and answer number 6 and number 7 in our notes and raise our hands. You have 30 seconds. Go, go, go. Raise your hands. Awesome. I see Stephen in the chat. 5 seconds remaining. All right, waiting on Tayan. Shelbs. Thank you, Shelbs. Omar, either send me a chat or raise your hand. Kale. Kamari. Timothy. Thank you, Jaden. Waiting on again. Tayan, Omar, Kale, Kamari, Timothy. Awesome, Omar. I see you. Tayan. Hello. Kamari, Timothy. Just waiting on you 3. Again, please respond. Otherwise, you will not be able to get your attendance. Let's go. All right, checking in with Tayan. Either raise your hand or send me a message. Here you go. Tayan, Kamari. All right, let's go ahead and keep on moving. All right, so this one right here, this one you need to be able to do on your own. We've practiced it 5 times actually, so far. So what is the molar mass of strontium? Again, you should be able to look at the square for strontium and find the molar mass. Don't put answers in the chat box. This is one that you need to do on your own. And then how many atoms are in 1 mole of strontium? How many atoms are always in a mole of anything? Again, this brings us back to our, come on computer, please type, brings us back to our, sorry, give me a moment. My tools are not working here. Brings us back to our, okay, we're going to just say Avogadro's number. Avogadro's number. Avogadro's number. Magic Avogadro's number. All right, here we go. This is number 8. You have 20 seconds to fill this out. Ready? Oops, sorry. Give me a moment. What did you do to my phone? Okay, don't touch my phone, please. All right, 20 seconds to fill this out. Go, go, go. Raise your hands. If you need help, I'm in the Q&A area. I'm in the Q&A area. But otherwise, please don't put any answers in the chat box. Yeah, it does look like avocado. There's a lot of memes and t-shirts and stuff that say Avogadro's number, but it's actually an avocado. All right, waiting on Skylar, Jaden, Timothy, Kamari, Taylor, Kale, Omar in the chat, or raise your hand. Derek, Michael, Christopher, Tayan. Again, each time I gotta say your name, you're slowing us down. So try to make sure you are participating quickly. We have the biggest class. That's part of the reason that we go over, is because I keep on having the same names over and over again. All right, looking good. Thank you. Jaden, you good? Hello? All right, I'm gonna go ahead and keep on moving. All right, everyone. So now we're going to go ahead and figure out how can we apply this to our compounds. This is why we reviewed how to read chemical formulas at the start of class. This is going to bring together the two things that we learned about, so that review and what we're learning about today. So we can actually use the periodic table to calculate the molar mass of a compound overall. All you need to do is take each element, figure out how many times does it occur in the compound, and multiply it by its molar mass. Once you do that, just add up all your results and you'll get the overall molar mass of a compound. Again, the overall mole, meaning 6.02 times 10 to the 23rd particles of that compound. Let's take a look at water because it's a lot easier to actually practice it. All right, so take a look here. How many hydrogens do you see in water? How many hydrogens do you see in water? Tell me in the chat. Yeah, we should see 2. And let's go ahead and take a look at the periodic table and figure out what is the molar mass of hydrogen. I did want to show you, who asked this? Shelbs, did you ask this? What is xenon? This is a picture of xenon. So xenon is a noble gas, and all the noble gases can glow like neon. That's where neon lights come from, but you can also have a neon light made from xenon. Yeah. So there you go. All right, let's take a look at hydrogen. What is the molar mass of hydrogen? Please take a look at this square right here and tell me what is the molar mass of hydrogen. Go, go, go. Don't forget your units, grams per mole. Awesome, I see Ignacio, Camilla, Shelbs. Yeah, perfect. It's going to be 1.008 grams per mole. That's what we see right down here at the bottom. So let's go ahead and drop back into our slides here, and we're going to fill that in. So right here, I'm going to go ahead and fill in that this should be 1.008 grams per mole. And if I multiply that by the number 2, what is my overall molar mass of 2 hydrogens? Go ahead and tell me in the chat. Grab a calculator on your phone or in your computer, or do the mental math. 2 times 1.008, what does that equal? Thank you, Ignacio. Perfect. I see people jumping into the chat box now. Yep, fill that in. Perfect. Yes, 2.016 grams per mole. That is how much 2 hydrogens weigh per mole. All right, perfect. Let's go ahead and now take a look at oxygens. All right, so how many oxygens are in water? It has no subscripts, so that actually counts as what? It has no subscripts, so that counts as what? Perfect, yeah. I see Jade Lynn in the chat box participating. I see Daniel. Yeah, it counts as 1 oxygen. So if we have 1 oxygen, we're going to go ahead and multiply it by its molar mass. So let's take a look at that. So here is oxygen right here. Tell me in the chat, what is the molar mass of oxygen? Again, take a look at that bottom number. We practiced that. Don't forget the units, grams per moles. Grams per mole. Perfect, Camilla. Thank you, Shelbs. Yeah, awesome. There we go. Let me jump back over to my playlist here. All right, so let's go ahead and take a look at that. So this right here is going to be 15.99999, and 1 times 15.99999 will still equal 15.99999 grams per mole. So let me jump that over here, 15.999 grams per mole. So now we have figured out how much a mole of 2 hydrogens weighs and a mole of 1 oxygen. Put it all together. We need to add these together in our calculators and figure out now what is the molar mass of water, of H2O. Go ahead, add those two numbers together. What do we get? 2.016 plus 15.999. Perfect, Camilla. Thank you, Jadelyn. Awesome. Don't forget those units. Ignacio, double check that calculation. I think you must have typed something in incorrectly. Awesome, Alan. Yeah, perfect. So you should actually be getting 18.015 grams per mole, and again, of hydrogen. So again, this means that if I have 18 grams of water, which is like 2 tablespoons of water, that means I'm looking at a mole of water, which means I'm looking at 6.02 times 10 to the 23rd particles of water, molecules of water. Molecules of water. All right, so if that's how much water you have in your cup, that's how many molecules you have. This is the answer to number 9. You do not need to include units because units were included in the question. So only write the number. Make sure you include the decimals correctly. Otherwise, the computer will mark it as incorrect. You have 20 seconds to raise your hand. Go, go, go. No worries, Ignacio. 10 seconds. Arya, Malin, Christopher, Shelbs, Angelo, Camilla, Kale, Ignacio, Kamari, Steven in the chat, Jaden, Timothy, Omar. All right, so let's see who we've got left. Kamari. Thank you, Steven. Kamari, Jaden, Omar. Either in the chat or raise your hand. Kamari, Jaden, Omar. Awesome, Omar. Thank you, Kamari. Jaden, hello. Jaden. If I say it in an English accent, will that help? Awesome. Thank you. We got 100%. Let's move on. All right, let's go ahead and do carbon dioxide. So carbon dioxide, how many carbons are in carbon dioxide? Oh no, Shelves. How many carbons are in carbon dioxide? It has no subscript, so that counts as what? That counts as what? Yep, that counts as 1. Awesome. Let's go ahead and multiply it by its molar mass, which is going to be what? Take a look here. What is the molar mass of carbon? Thank you, Shelbs. Thank you, Camilla. Awesome. Yeah, perfect. So going back over here, so I'm going to go ahead and be multiplying this by 12.011 grams per mole, which is easy peasy. We know that that just equals 12.011 grams per mole. Awesome. So we've got our molar mass from carbon. Let's go ahead and figure out the oxygens. How many oxygens are in CO2? How many oxygens are in CO2? Thank you for letting me know, Omar. Take a look at the subscript. Yep, there are 2 oxygens, and we already know the molar mass of a single oxygen. That was 15.999 from the previous slide. So multiply that together. What is 2 times 15.999? 2 times 15.999. Work quickly. We got 2 minutes left, and I still have a whole question to go over. Let's get it done. Yes, Steven, double check that. I think you got to ditch it off. Yes, perfect. You should get 31.998 grams per mole, and let's add that all together. What do we get? Add that all together, and what do we get? So we now know the molar mass from 1 carbon, the molar mass from 2 oxygens. Put it together. What do you get? I'm sorry, Shelves. I know. I don't actually use real calculators anymore, so my batteries are all dead on my real calculators. Thank you, Camilla. Awesome. What are we getting? What are we getting? Do we agree with Camilla? Are we getting something different? Get your answers in the chat. 12.011. Hello? I need answers in the chat box. I'm not asking for raised hands yet. I need answers in the chat box. What is my answer here? Come on, the longer I gotta wait, the more time we're gonna have to take to go over ammonia. Thank you, Ignacio. Thank you, Canyon. Perfect. Yeah, we should be getting 44.009. This is going to be the grams per mole of CO2. So again, if I have half an apple's worth of CO2, that means I have 6.02 times 10 to the 23rd atoms of, or molecules of CO2. This is the answer to number 10. You do not need to include units. Go ahead, take 20 seconds, fill that out, raise your hand. We still have one more question to go over, and then I will give you your attendance. Go, 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 raise your hands, work fast. Thank you, Stephen. I see you in the chat. All right, Omar in the chat, Timothy, 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 Skylar, 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 Jaden, 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 Derek, Derek, Bryce, Bryce. Thank you, Omar. Bryce, 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 Jade Lynn, Aria, Aria, Patrick, Patrick, Jaden, 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 Timothy, Timothy, Timothy. Thank you, Skylar. All right, Jaden, hello, hello, Jaden, 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 Timothy, 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 hello, hello, hello. Jaden, 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 last chance, please respond. All right, let's go ahead and do ammonia really quickly together. How many nitrogens are in ammonia? How many nitrogens are in ammonia? Excellent. It has no subscript, so this counts as 1. I'm just going to tell you that the molar mass of a nitrogen from our periodic table is 14.007. So if we multiply that by 1, we should still get 14.007 grams per mole from our nitrogen. Now, how many hydrogens are in ammonia? Take a look at its subscript. How many hydrogens are in ammonia? Yep, there are 3. And remember that from our previous slide, the molar mass was 1.008 grams per mole, which if I were to multiply that 3 times 1.008, you should get 3.024. 3.024 grams per mole of our 3 hydrogens. Now, all I'm going to ask you to do, go ahead, grab your calculators, add those together, and then we can go over attendance. So do that quickly. What do you get when you add those 2 numbers together? Thank you. I see Jade Lynn participating. Let's finish strong, participate, so we can get to our attendance and our weekend and make sure that we're learning and practicing. Thank you, Camilla. Thank you, Ignacio. I see Bryce. Awesome. There we go. Getting more answers. Perfect. Yes, you should be getting 17.031 grams per mole. Again, that means that if we have like a slice of apple's worth of ammonia, that means I have 1 mole of ammonia. That means that I have 6.02 times 10 to the 23rd molecules of ammonia. This is going to be our answer to number 11. Please raise your hand when you have this saved. You have 20 seconds, and then we will do our attendance. Thank you for working so hard. I know we went a little bit over, but again, remember, the faster we participate, the less I have to say those names over and over again. 10 seconds. All right, Bryce, Bryce, Annabelle, Annabelle, Patrick, Patrick, Angelo, Adriana, thank you, Adriana, Canyon, Canyon, Kale, Kale, Kale. Thank you, Kamari. Stephen and Omar, I see you in the chat. Kale, 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 you're my last person. Just waiting on you. We're just waiting on you. Come on. Thank you. Perfect. 100% awesome. Let's keep on going. So today we talked about how many atoms are always in a mole, 6.02 times 10 to the 23rd. We figured out when we look at the periodic table that mass can be the molar mass in grams per mole of an element. And then we can use that and multiply it by however many times we see the element in the compound to find the molar mass of a compound. Excellent job on that, everybody. You worked really